Hi, welcome to my video on Descartes' rule of signs, part 1. This is for the positive and negative signs polynomial. Descartes' rule of signs. The number of positive real zeros in the p of x is equal to the number of changes of the sign in front of each consecutive term, or is less than this by an even number. Let me explain. So the p of x is given in each. Each of these are the p of x. So when I look at this polynomial, then the change, this is a positive and this is a negative. So I'm doing this to indicate that there's one change. So there's one change. So that means it has one positive real zero, because there's no more to have. And if you think about it, if you let that equal to 0 and solve it, you get x is equal to 1, which is positive. B, let's check with the sign changes as we move to each consecutive. Positive to a positive, no sign change. Positive to a negative, one sign change. Again, it has one real zero. And let's look at C, the sign change. Positive to a negative is 1. Negative to a positive is 2. So there's two sign changes, but when you have sign changes, it decreases by even numbers. So you can have a 2 or you can have a 0. So you can have two positive real roots or no positive real roots. D, notice that the x is missing in the descending order, but that doesn't make any difference. This is a positive going to a positive, so there's no sign changes. So there's no positive real roots in this binomial here. And also notice that this is positive, so you think that when you put any number in here, then the x squared, no matter what number I put in x, the x squared is always positive. So if this is positive and you add on 1 as positive, then that means that for any value of x, the y in the graph is always positive. And if you think about it another way, think about it as this way: y equals x squared plus 1. What you have is a parabola whose vertex is 0, 1, which is right here. When x is 0, y is 1, and it's opening upward because it's positive. So that's a parabola that's opening up like that. And no matter what value of x you sub in this equation, into this expression, the y is always 0. So that's why there's no positive reals. And what it means is that if you look at it from another point of view, if you let y equal 0, x squared plus 1 is equal to 0, x squared is equal to negative 1, the square root of x squared equals plus minus the square root of negative 1. X is equal to plus or minus I. So the more to make this true, we have imaginary roots that fills in here. Again, let's continue. Descartes' Descartes' rule. Positive to a negative, one change. Negative to a positive, another change. Positive to a negative, another change. So there's three changes. So 3 take away 2, you can have 3 reals or 1 real. Let's look at this one. Negative to a positive, 1 change. Positive to a negative, 2 changes. Negative to a positive, another change. And positive to a negative, another change. 1, 2, 3, 4. So that's 4 possible changes. And we go down by 2, so 4 take away 2 is 2. Go down by 2 again. 2 take away 2 is 0. So we can have 4 positive reals, 2 positive reals, or 0 positive reals. And look at G. Notice that every coefficient here is positive. So this is like this one. These are all positive. These are positive. So you can't have it. In order to have this equal to 0, the x must be negative. So there's no positive change, no positive change, no positive change. So that means there's no positive real roots here. Again, in order to make this 0, we must have negative values of x. Same with here, we must have negative values of x. So that's why there's no positives, and there's no positives here. There's no change in the signs. But you can see by looking, because we have all positive numbers, it must be negative numbers. That will give me a 0. And look at this one. Positive to a negative is 1. Negative to a positive is 2. Positive to a negative, that's 3. Negative to a positive is 4. Negative to a positive. So we got 1, 2, 3, 4, 5. And we go down by 2, we get 3. Go down by 2, we get 1. So there's 5 positive real zeros, 3 or 1. And let's look at this one. We got a positive to a positive, no change. Positive to a negative is 1. Then we go down by 2, we get a negative. So there's only one change. Right here, negative to a positive is 1. No change, a change, and a change. So there's 3 changes and decreased by 2, so it's 3 or 1 positive real zeros. And k, now we have to put it in descending order. So we have to put x to the 4th first, then x cubed, then the x squared, and then the x, and then the constant. So 1, 2, 3, 4, 5, 4, 3, 2, 1, perfect. 1 change, 2, 3, 4. So that's a 4, a 2, or a 0. So that's possible. That's the number of possible positive real roots. Now, the Descartes rule also has a negative real zeros. The number of negative real zeros in the p of negative x is equal to the number of changes of the sign in front of the consecutive terms, or less than this by an even number. But we put in p of negative x. So if this is the p of x, then we put, if we say this is the p of x, so now we're looking at the p of negative x. So we're going to put a negative x in the place of x and check the sign changes. No sign change, so there's no negative real roots. So this is the negative x right here. That should be a negative x. So now we're going to do the p of a negative x for this one. So we're going to sub in negative x and simplify it. Negative x squared is x squared. Negative times negative is a positive, and negative 6. So we have no sign change, one sign change. So there's one positive negative real root. So putting negative x in the expression in the place of x and looking at the sign changes tells us of the possible number of negative real roots. And again, this is positive. So we put, again, we're going to put a negative x in. So we're doing the p of negative x. Negative x squared is just x squared. Again, it didn't change because of the square. So there's no sign changes. So there's no negatives, real roots in this one. And again, we're doing the p of negative x. So we're putting negative x in the place of x. So negative x cubed is negative x. The negative of x all cubed is negative x cubed. Negative x squared is positive, so that's a 4x squared. 3 times negative x is negative 3x, negative 6. One sign change, 1, 2, 2 sign changes. So it's 2 or 0 possible negative real zeros. And right here we have the p of negative x. Negative x to the 4th. Negative x. Negative x to the 4th power is same as positive x to the 4th. Negative times negative is positive. And we get negative 1. No sign change, one sign change. So there's one possible negative real root. And now, rather than sub them all in here, what I'm going to do is just pretend I'm putting it in. Watch. This is a negative x now. So if you put a negative x here, that's negative, so that makes it a negative. If you put negative x here, that makes it still positive. Put a negative x here, and that makes that negative, so 2 times the negative. And negative x going and squaring is still going to be positive. Put a negative x here, we get negative 4, and this is a positive. So without putting the negative x in like this, just pretend you, in your mind, you put it there and say, is it going to be plus or minus? So 1 sign change, 2 sign changes, 3 sign changes, 4 sign changes, 5 sign changes. So it's a 5, go down by 2, 3, or 1 possible negatives. And in this one, we have to have it in descending order. So we got 4, 5 is the highest. 4 is next. Cubed is next. Square is next. 9x is next. And a constant of negative 7. And again, we're going to put in the p of negative x. So we put a negative x here, it'll make a negative. Put a negative x here, and I'll have a positive. Put a negative x here, and I'll have a negative. Negative x here, I'll have a positive. Negative x here, I'll have a negative, and a negative 7. So again, you don't have to put a negative x in, because this is for you to do, to see how many possible negatives. So 1 sign change, 2, 3, 4, no. So there's 4, go down by 2, go down by 2 again. So 4, 2, 0. Possible negative real roots. Okay. Now let's do both. Let's do the positive and the negative real roots. So right here, we're looking at the positive real roots. No sign changes, they're all positives. So there's no sign changes on the positive zeros. Let's look at the negatives. So we put a negative here, it gets a positive. We put a negative here, we get a negative, and that's a positive. So we get 1, 2. So you get 2 negatives or no negatives. Okay, let's look at this one. Don't forget, you can pause your video and work these out. So let's look at the sign changes for the positives. No. 1 sign change. Now let's look at the negative. We're going to put a negative x in here. Negative x cubed is negative. Negative x squared is positive. Put a negative x here, and I'll get a positive and a negative. So we have 1, no. So we have 2 sign changes or a 0. Okay, let's go with the fourth term. So we have positive to negative is 1. Negative to negative is none. So we have 1 positive real root positive out of 4. Now we're going to look at the negative. Negative x to the 4th power is positive. Negative x squared is positive, so that still remains a negative. And we got a negative 4. So we have 1 sign change. This is not. So we got 1 positive, 1 negative. And you say, well, there's 4 roots. Where are they? Well, that means that there's 1 positive, 1 negative. We also have the idea of looking at the imaginary roots, which I'm going to look at in the next video. So it's 1 positive, possible 1 positive, possible 1 negative. And right here, look at the positives. We have 1 sign change, 2 sign changes, 3, no, no. So that's a 3 possible positives or 1. Now we're going to put a negative x in. So put a negative x here, we have a negative. Put a negative x here, we have a negative. Remember, a negative x to the 5th power gives you negative. And a negative to the 4th power is a positive, so that makes it negative. And negative x cubed is negative. Negative x squared is positive, and negative of a positive is negative. negative x, the negative of a negative x is positive. And we got negative 2. So in terms of negatives, no, 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 1, 2. So we got 2 negatives or 0 negatives. And we got to put this one in descending order. 4, 3, 2, 1. Okay, x to the 4th. Negative x cubed. Positive x squared. Negative x plus 1. And now we look at the positives. So we got 1 sign change, 2, 3, 4. So we have a 4, go down to 2, to 0. So we can have 4 possibles, or 2 possible positives, or 0 possible positive. Now let's sub in negative x. Put a negative in here and becomes a positive. Put a negative in here. So negative x cubed is negative. Negative of a negative is positive. Put a negative x in here, we still get a positive. Put a negative x here, and we get a positive. And we get a positive. So notice we have no negatives, no sign changes. So that's explaining Descartes' rule in relation to the sign changes, and that tells us about the possible number of positive roots and the possible number of negative roots. In the next video, we'll take that Descartes' rule one step further. If you like my video, click the like button, click the subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Excuse me. Bye-bye.